I would like to walk you through one of the ways you can contribute to BitVM. BitVM is a fun new development on Bitcoin where it was discovered that we can add logic gates and circuits into a Bitcoin script. These logic gates are essentially what your computer does at the most basic level, which means this has the potential for us to run interesting functions within a Bitcoin script. So to start, if you are unfamiliar with logic gates or if you need a refresher, I like this website called NandGame. This is kind of a fun gamified way to learn these circuits. You have to create, this first level we have to create a NAND gate. This is not AND. So if we see the inputs and the output, we need to make the output come from these inputs using these relays. These are kind of like switches. So if I connect them, I can connect one to the power here, which is always on. I connect the other one to B here, right? This almost acts like a switch, right? If I hit B, if I flip B to 1 instead of 0, right now the output of this switch is 0, you know, and back and forth. So we can kind of line these up in whatever way you want. I can use the input of one to go into the other, and yeah, eventually I can connect the output here, and we see which ones we have passed, right? So I need it such that when both of them are 0, the output is 1. I failed at that and I failed at this one, but I happen to succeed at these other two, right? So I'm not going to spoil it for you. I'd like you to figure out by yourself how you make this NAND gate. But once you have the NAND gate, then through the next levels, you use that gate to create some of these other logic gates, do interesting arithmetic stuff. I'm going to hop forward. This is one of the functions I like, the selector. With the selector, we have 3 bits. The first one is the selecting bit. And then if this is 0, we're going to pass the last bit to the output, this D0. And if the selector is 1, we're going to pass this D1, the second bit here, to the output. So it's fun to see. This is already built here for you. And so, you know, if this is 1, it's passing D1 to the output. We see that. If I flip it back to 0, it's passing D0. Whatever I have as D0 is going to get passed to the output. And if this is 1, you know, whatever D1 is, will get passed. It's kind of a fun function. You know, does something a little interesting. What I would like to do next is I'm going to take this function and then I'm going to recreate it in Python. And then with Python, again, after recreating this circuit here, I will output it in a way, in a format that can be used easily, can easily be plugged into BitVM. So anyway, so we've got our selector circuit here. I'm going to hop over to Jupyter Notebook. If you're not familiar with Jupyter Notebook, I think this is the best way to do Python. In the command line, you're kind of stuck where you're at, but here you can separate different sections of code and run them, you know, one at a time. You can go back and edit something and run it again. So anyway, we are importing this module circuit. We're importing just a couple of things from it, but this circuit module is what's going to allow us to build our logic circuit. And then I'll talk about this next one in a second here. But yeah, so here we've got this selector circuit. C is the circuit. We're starting there. And then next I've got the 3 inputs. So these 3 gates are my 3 inputs right here, the selector, D1 and D0. Same thing here. I've commented out, right? I'm intending for this to be the selector. I'm intending this to be, you know, D1 and this to be D0. After that, I've got the logic gates that these inputs are running through, right? So I have this is the invert gate over here. So I'm inverting my selector before passing it through to that AND. Over here, it's the NOT operation. I'm essentially, same thing, I'm flipping what this is supposed to be, right? If it's a 0, NOT turns it into a 1. If it's a 1, NOT turns it into a 0. So I have, I do that to my selector, and then I have my first AND gate passes the selector and D1, which is G1 here. Then this next AND gate passes the opposite of my selector, the not my selector, and then the other bit. And then finally we do OR, and this is on G4 and G5, which again are my two AND gates. This is exactly, again, what I built here, right? These are the two inputs to the OR gate, and then I get my output. Unfortunately, the way this circuit works, I have to define the output in its own gate. So here we go. This G7 is the output. Is output is true. I just passed G6, which again is the result of this OR gate. So then I can evaluate this. I've got here just evaluating one case. Oh, I did not run this part yet. There we go. Now C is defined. So this is, the first part is 0. So I am looking at the last bit that passed through. We're good. I can also, again, we're in Python, so we've got for loops and things like that, so we can run everything at once. This is, you can see exactly my inputs and outputs match exactly what we have here as well. So everything lines up, everything works as intended. Again, just a note on the for loops and us being in Python, I didn't have to name these one after the other. I named them, you know, G0, G1, G2, and so on, so I can keep track of them. But if I had a much more complex circuit, I could, you know, label them something more descriptive. You know, I could say, you know, I could call this selector, you know, equals this gate, you know, and this is not selector, right, and so on. I can name them more interesting things. You can also run for loops within here, right? I could, if I had 20 inputs, instead of repeating this line 20 times, I can, you know, say for in the range of 20, and then just create 20 gates that way. So anyway, fun things you can do there. The last step, the final step, is this BFCL. Just to note, I've had trouble with this. I don't know why, but it was not importing all the functions I needed. So what I did was I imported these two supporting classes, the gate and operation, and then I just copied from the source file itself this other class that it was not just not cooperating with me. So anyway, so I'm going to run that before I run this, and this it just emits BFC. It's Bristol fashion circuit. This is a different way of presenting a circuit here. So obviously we see some of the ands, the invert in here, but yeah, anyway, I would not have come up with writing this like this on my own. So this is something that the BitVM in its current state can read, and so what I would do is I would pass this off. Super Testnet is the one who has put functions already into BitVM, and he is very helpful. And as long as you have something in this format, he'll be able to put it into a Bitcoin script and then put additional things around it as needed. I'll have a link to his channel in the description. I think he's a great one to follow. And then I also have a link to the Telegram group, the BitVM developers. So feel free to jump in there, share your talents at any level, right? Whether you want to make functions, fun functions to run within BitVM, or whether you want to have some of these higher level discussions of what is possible and not possible within BitVM, or if you simply want to learn more and help spread the word about what BitVM is doing. So feel free to join that Telegram, share your talents in any way you can. You know, if you are looking to get more into building circuits, I can make more videos where we can build some more complex circuits in Python or even in NandGame. I think both are kind of fun to use. Anyway, I hope this was helpful and helps you get started and inspired to do something even cooler. And with that, good luck building.